Yes, sir.
Then good morning. We had a break of the class due to my visit to BSMRU campus. And today we shall discuss on a new topic, uh, feeding preference, feeding preference of vertebrates including man. In this earth, there are thousands of millions of species, uh, plant and other animal species, but we get nutrition and we use as food a limited number of species. In case of plant, around 15 to 20 species all over the world. In that case, there might be some reason. Feeding preference of vertebrates, including man, is very important, and it has been understood that ecological chemistry is playing a vital role in limiting the uh, or triggering the preference of vertebrates, including man, to which plant or animals will be used for their food purposes, because we need uh, several nutrient for our um, healthy life from plants and animals. We need protein, we need carbohydrate, lipid, vitamins, minerals, and obviously water. But we are getting these all these elements. Our body cannot make anything from the uh, other organisms. So feeding preferences of vertebrates and invertebrates is really important. What factors regulate feeding preference of animals? This is important question. Chemical substances can play a role in feeding, social and reproductive behavior of mammals. The chemical of taste and smell are detected in by men or women by receptor sites in the mouth and nose, and mass is known because olfactory system already we know how we taste, how we smell at molecular level has been established. So these receptors over the years of evolutionary process, they are developed. Sweet taste is more easily sensed on the tips of the tongue. Sweet taste is more easily sensed on the tips of the tongue. The bitter taste at the back, and the sour taste at the edges, and the saltiness on the tip and at the edges. So the receptors are densely located on the specific side of the tongue. So we can test different uh, chemical substances. Some are sweet, some are bitter, some are salty, some are sour. So sensitivity of test buds, especially they have huge sensitivity. Uh, a sodium chloride concentration of about 0.5%, and that for bitterness is at a concentration of brucine of 0.001%. Sodium chloride, small amount is essential for our food. Otherwise, we cannot get the taste. But if its concentration is higher, then it tastes bitter. You cannot take the food. Similarly, other compound, very low concentration brucine is also a beta test. Selection of food by man and other mammals is inevitably a complex matter involving flavor, taste, palatability, color, and odor. So these are, five important factors that regulate the uh, choices of the food, flavor, taste, palatability, color, odors. Some item may be very nutritious, but flavor, taste, palatability, color, odors are not compatible to the animal or human. They cannot uptake it. Other issues also exist here, the cultural or religious issues. So, for example, pork meat, uh, uh, beef, all people cannot accept it due to religious and other cultural matters. Human tastes are classified within four groups: salty, sweet, bitter, sour. The palate can respond to and recognize a variety of shades within these groups. And similarly, the human nose can differentiate between many scents and colors. Colors our eye can easily recognize, and and scent obviously in case of many food items. So these are the sensitivity issues in our taste buds. Here, this table was taken from the book of Professor J.B. Harborn, uh, Introduction to Ecological Biochemistry. Here you can see some characteristic odors and chemicals that can represent them. For example, almond-like odor. Basic chemical is nitrobenzene. Uh, Aromatic odor, benzaldehyde, aromatic. Burnt odor, uh, methyl benzoate. Cool odor, camphor. Disinfectant, phenol. Fecal odor, scatol. Fishy odor, trimethylamine. Floral odor, hydroxycitronellal. Fragrant, beta ionone. Fruity odor, benzyl acetate. Am I audible now?
Yes, sir.
Yes, sir. There was a little bit interruption. Anyway, this is the list of some characteristic odors and responsible chemicals. For example, uh, metallic odor, N-nonyl acetate, minty odor, menthol, musk-like odor, exaltolide, onion-like odor, dimethyl sulfide, petrol-like odor, benzene, rancid odor, valeric acid, soapy odor, stearic acid, sour odor, acetic acid, sparmous odor, a pyrrolene, spicy odor, eugenol, and sweaty odor, isovaleric acid, sweet odor, vanillin, vanillin ice cream, obviously you love it. So these are the chemical compounds responsible for today. Internet is disturbing, right? What are the
Yes,
industrial use of these chemicals associated with the odor? These chemicals have been industrially used in different, processed food. So, if, for example, vanillin is used in vanilla ice cream, or some other order used in different food products industrially prepared so that uh, people get feeding preference. Here feeding preference of vertebrates uh, is changed in different way. You see, concentration is very important. I told you in case of sodium chloride, you see lower concentration That means millimolar concentration around 1 millimolar, the preference is high, but gradually it goes down. Acetic acid also, higher concentration, feeding preference dramatically decrease. But in case of glucose, higher concentration, feeding preference increase because it is sweet. And in case of sweet material, some of the cases, higher concentration is good. In case of quinine, you see higher concentration in the solution because it is beta test, feeding preference decrease. So feeding preference is associated with the concentration of the materials. For example, glucose, fructose present in the fruit. If orange or some other or guava is contained glucose and fructose higher concentration, their price would be very high because they would be sweeter. Sweeter, some fruit people love very much. Feeding tannin and alkaloid contents of plants eaten or avoided by the black and white colobus monkey. That means in the nature, organism or animals can even sense the concentration of different secondary metabolites like tannin and alkaloid. Here it is shown that different ages of the plant, young or mature, plant species, different plant species, and frequency of consumption. That means young plant are consumed highly. For example, Celtis durandi by the colobus monkey, because here you can see tannin concentration is low and alkaloid concentration is low. But when concentration of tannin and alkaloid is increased, then, for example, uh, mature Trema orientalis plant or Marcahamia platicalis plant not eaten because they contain 81.5 milligram per gram tannin, because tannin is astringent test, not good test. And astringent test you can find in our country persimmon like gab, raw gab. If you take astringent test, kosti or like that, and mm, also here you see alkaloid concentration is high. So high alkaloid concentration, high tannin concentration. This is an example. Can limit the uh, you know uh, uh, feeding preference of the vertebrate. Similarly, feeding preference of invertebrate like insect also regulated by the presence of different metabolites. Structure of coniferal benzoate, a feeding deterrent of the raft grouse. Raft grouse, that means bird, due to the presence of this coniferal benzoate, uh, feeding is deterred, that is limited. Similarly, uh, feeding a correlation between food plant choices by Canada geese and the soluble phenolic content of the leaves. So scientists analyzed. They found that in case of phenolic content also, there are frequency of feeding is hugely varied. Here you see phenolic content concentration, and here is the feeding frequency. In case of limonium, carolinum, feeding frequency is zero because it contains high amount of soluble phenolics. Although soluble phenolics are good for as antioxidant, but higher concentration is problematic for the animal, and this is why they avoid it. Chemical components of fruits and vegetable flavors. This is very interesting table. Apple. Apple fruit has a unique flavor. uh, and banana unique flavor. For example, jackfruit, you can easily understand, even in a dark room, there is jackfruit, you can understand the smell. Mango, you can understand the smell. So uh, scientists discovered the components identified as flavor principle. For example, in case of apple, ethyl 2-methyl uh, butyrate, and banana, amyl acetate or amyl propionate or eugenol. Three compounds are responsible for the unique aroma of or flavor of the banana. Coconut, alpha nonylactone. Grapefruit, you see nutcatone and other compound. Lemon, citral. Mandarin orange, methyl and methyl anthranilate and thymol. Mango, car3 and or dimethyl styrene. And quince, ethyl to methyl butanoate. And peach fruit, andecalactone. Pear fruit, ethyl trans 2 cis 4 decadienoate. Raspberry, similarly another compound. Vanilla, vanillin is the main component in the vanilla fruit. Vegetables, for example, bell pepper to isobutyl 3 methoxy pyrazine. Celery has also specific or four compounds responsible for the the aroma of the celery. Cucumber, cucumber you love shosha. Here is the compound responsible for the aroma of cucumber. Garlic also, onion and mushroom, lanthanoid. So these are the chemicals already been synthesized by the synthetic chemist, and they have been used in uh, you know, industrial purposes to make, various processed food products. Uh, uh, this is why industrially very important. Here is the some compound, for example, ginger, gingerone, or gingerol. They are, aromatic phenolic compound. Ginger officially produce paradol. Curcuma longa, turmeric, that is holud. Capsaicin, morich. Capsicum anam, the pungency related compound. It is a white compound actually, white powder, incredibly hot. And piperine in piper nigram, in the pepper, that is gulmorich, you can find this compound, and this is responsible for the pungency. So these compounds are responsible for the pungent odor or like that. So yes, there are huge studies on sweetness of the sweetness chemistry of sweetness of different food products. Relative sweetness in organic chemistry always considered from the sucrose. So sucrose sweetness is in the scale considered 1, and then all other sweetness is considered how stronger than the sucrose. So glucose is less sweeter than sucrose. Fructose a little higher sweeter than the sucrose. But there are, you see, lots of compound like cyclamate, glycyrrhizine, aspartame. Aspartame, a synthetic compound, 200 times higher than the higher sweeter than the sucrose, and it is used as a gerucal because glucose, sucrose, fructose, they generate calorie, and this is why if you want to get the Jirucal in, and now it is a trend everywhere, you can find Jirucal. People use saccharin, people use cyclamate or aspartame, but stevia, a plant, uh, you know, uh, uh, glycoside, terpenoidal glycoside. Stevioside is 300 times higher than the uh, sucrose, and it is available in our country. Stevia plant. Stevia plant leaf can biosynthesize stevioside, and it is a heat stable compound, so easy and water soluble. So easily from the plant you can separate. Even if you put two or three leaves of stevia plant in your teacup, it would be enough to sweeten your tea, and it is very very good for the health. And Japanese people, they have been using steviosides or stevia for last 50 years, and there is no side effect. And this metabolite, secondary metabolite, is highly stable in our intestinal system. So you would get only the sweetness to satisfy your palatability, but you would not get any calorie. That means it is a 0 calorie natural sweetener. But saccharin is a synthetic one. Saccharin is 500 times higher than the sucrose. Naringenin, dihydrochalcone, sucralose, Hernan dalcin, new hesperidine dihydrochalcone, protein or tomatin protein. Tomatin protein you see 5,000 times higher than the sucrose. But all of them, except glucose, sucrose, and fructose, they are not offering you any calories, so you can get the test. In case of saccharin, after test, first you get the sweeter and then a little bit bitter. And saccharin, there are lots of literature. If you take too much, it is a synthetic compound accidentally a scientist discovered during synthesis of carbohydrate. And this compound uh, has aftertaste, and as well as some health hazardous problem if you take too much. But anyway, glucose, sucrose, fructose, well adapted to animal and human, but other these sweetener, which are 0 cal, not yet proved that they are safe, because sucrose we take too much from the sugarcane or the sugar beet. But others now, as 0 cal has been started to commercialize, and worldwide you can find lots of 0 cal in the restaurant, or even people use in the country. I had some work on stevia and steviosides. In 2006, I wrote an article on stevia and steviosides and other these 0 cal uh, sweetener. You can find it in internet also. Is there any natural alternatives to sugar? Because sugar for the diabetic patient is really problematic, and it was, a huge stimulation to the society. In 2006, I published that article in Financial Report, and it was through online, worldwide, it was stimulated. One secretary from Singapore, he was at that time a full secretary in the cabinet, and he asked me to support him. He wished to introduce stevia and stevioside in Singapore, because he was a diabetic patient. And there were lots of stimulation, even stevia, stevicide. After that, many Bangladeshi traders, they imported, and now it is available in Bangladesh in the market. But here you see, due to slight changes in the structure, for example, naringenin is bitter. Bitter test always considered comparing with quinine. So it is uh, less bitter than the quinine anyway. But when it is isomerized Then naringenin 7 rutinoside, no test. But when ring opening and reduction is taken place, naringenin dihydrochalcone 500 times sweeter than the sucrose, and this is a natural product. And possibly it has no problem as no problem associated with health hazard if you take small amount as the sweetener. A new hesperidine dihydrochalcone 1000 times as sweet as sucrose. So they are commercially very potential to use as zero cal sugar and give us sweet taste. And the structural requirement for sweet and bitter receptor site in man. Here you see in the this is methyl alpha D monocyte. This end is bitter end and this is the sweeter end. So there is the binding site of the receptor. A receptor is a protein present in our tongue for sweet and bitter taste. So receptor protein and small molecule sweet substance, if they fit well with the receptor, then the sweetness is increased. So saccharin, you see, it is an aromatic compound and synthetic compound. Aspartame is like this, and it is they are commercially available. Cyclamate is also commercially available. Stevia, the structure is like that. It is a terpenoidal glycosides. Here you see glucose is present there, but even though glucose is present there during human metabolism, this glucose atom is not removed, and they are found after intake. They are excreted from our body, not metabolized, and not release any energy. But stevia intake in different animal experiment found good for the health in many ways. Hernan dalsin, another aromatic compound, it is also highly sweet. So flavor potentiators and modifiers. Flavor potentiators and modifiers are very interesting. Not directly, flavor, but they can modify or enhance the flavor. For example, the most familiar potentiator is sodium chloride, monosodium glutamate, and purine based 6 dihydroxypurine 5 mono nucleotide have been used in the industry, testing salt or sodium chloride, obviously, the table salt. If you do not use these compounds, especially sodium chloride, in any food, you cannot take. That means they are powerful potentiator. And monosodium glutamate in Chinese and other food, people love it very much. Flavor modifier, for example, miraculin, and the name you can understand it has a miracle properties. A glycoprotein occurs in the miracle fruit found in Africa. This compound has property of eliminating sourness or acidity without disturbing the sweetness. Very interesting. A mixture of pentacyclic triterpenes, the gymnamines, which occur in the leaves of Gymnamia sylvestre, it works like miraculin. Miraculin, what it can do, for example, if you take miraculin small amount, and after that if you take sour lemon, if you feel like a sweet lemon, so it has a miracle principle. Sometimes amloki, if you take amloki and if you take then water, you feel a bit sweet taste. So this is all about today's talk. We can discuss a little bit.
As you have said, after eating amloki and then taking water feels sweeter. But is water is something like that miraculin, or what happened there?
Please ask your question again because the sound was not clear. Joy Gopal, right?
ইয়েস স্যার। স্যার
Joy.
আমি বলতেছিলাম হচ্ছে ওই আমলকি খাওয়ার পর পানি খেলে একটা মিষ্টি স্বাদ আসে।
Hmm.
তো এই পানি খাওয়ার পরে মিষ্টি স্বাদটা কেন? পানি কি
Uh,
অনেকটা মিরাকুলিনের মতো কাজ করে নাকি
Not
কেমিক্যাল?
water is not working miraculin, but you know, amloki, it contains, like how to say, citric, not citric acid, L-ascorbic acid at high concentration, and there are lots of other compounds there. Some of the compounds, I'm not sure which one works like miraculin, but it is an interesting subject to explore.
থ্যাংক ইউ স্যার।
Welcome. Because if you take L-ascorbic acid tablet, and after that, if you take water, you cannot get the sweet taste. That means not L-ascorbic acid, possibly other molecules present in amloki, unknown molecule. You can check in the literature whether someone already discovered. After that, if you take water, you get, sweet taste.
ইয়েস স্যার।
Okay, thank you. Any more question? Rahat.
Glucose and stevia, both are so bad patients, and stevia is actually a good one.
Yes, glucose is sweet, and stevia also sweet. But stevia contains glycoside, glucose atom also. But in case of stevia, it is a triterpene glycosides. It is not metabolized in our body, but it can bind with our sweet receptor, give you the sweet feeling or taste, and it is 300 times sweeter than the sucrose. But in case of glucose, glucose can easily uptake in our body and moves to the blood stream and increase the blood glucose level. Uh, and if a diabetic patient suffers from, deficient in insulin supply, in that case, glucose level go up and it interferes the metabolic process and blood pressure and other serious consequences. But in case of stevia, it is not uptaken by the blood and it is not metabolized in our body, but you can get a, sweet taste. And it is obviously zero cal because not offering you calorie, and glucose offering you calorie. So glucose is good for if you are calorie requiring hard working man, glucose is good. But if your metabolic system uh, suffers from enough insulin supply, that is diabetic patient, for diabetic patient glucose is a poison like substance. Clear, Rahat? Do anyone have any question?
Yes.
Sound is a bit not clear, Rahat. Please check your microphone. And how about others? Sorordi and Ruhul Amin?
Uh, Today internet is not good.
Yes, internet is
Yes, sir.
interrupted.
Yes, sir.
Assalamualaikum, sir. I have a question. In the
Ruh Amin,
Yes, sir. Sir, can you hear me?
I hear you very clearly.
Okay, sir. Nowadays, diabetic. In case of diabetic people, they're very much fond of the uh, diabetic sugar-free food, such as biscuit, diabetic sugar-free biscuit. So in that cases, in case of my opinion, I I cannot get too much taste in that in these types of food which contain less glucose. Can we maintain the glucose like taste in the food, but the actually the energy those they receive from glucose that can be destroyed. I want to mean that we'll provide food that has glucose like taste, but it will contain very much less amount of energy.
Yes, in Japan, most even Coca-Cola and other processed uh, drinks and foods, they use stevia. Stevia is a natural sweetener, so it is very good for their health. No calorie, but getting the good taste, as you mentioned, sugar-free biscuit. So sugar-free, but stevia containing the biscuit or even Coca-Cola is very good. But in our case, the Coca-Cola, we are taking huge amount of sugar, and huge amount of sugar if you do not have regular hard physical work, it is problematic and create serious pressure in the bloodstream. uh, this is why natural alternatives, if we can use as sweetener, is good. But obviously we get sugar, glucose, fructose from the fruits, as well as from the rice we get lots of carbohydrate, which ultimately break down into the glucose. So in case of glucose level, whatever your age is, you should maintain it if you want to keep it fit. We need around 2200 kilocalorie, energy for an adult person. But if you take 4000 or 5000 kilocalorie per day, you will face obesity and some other problems. But if you are crazy to get, sweet material, uh, in that case, natural alternative of sweetener like stevia would be good choice to use in your case instead of glucose and instead of sucrose.
Thank you, sir.
Welcome. Any more question? No question? So you have one exam Saturday, another exam 611 Sunday. Remember it. Especially Ruhul Amin and Sorordi. So in case of exam, I can give you some instruction. I shall send you the question and also the time. So for example, 3 hours time, I shall send some questions. So you can see the internet or you note or anything else, but you must send me back your answer script within the timeline. Otherwise, I will not accept it. Okay?
Okay, sir.
Okay, sir.
Then thank you so much. Have a good day.